The test will cover chapter 5 and 6. So on these sample exams, what you will see is maybe one big problem like you see here, where it's a linear programming problem. You might have mixed constraints. Some are less than, some are greater thans. My intent on this problem is that you would solve it using graphing. So don't try to use Simplex on this, because Simplex will not work on this one. Because most of the regions that I give you will not just be first quadrant regions. Notice we don't have the x1 greater than or equal to 0, x2 greater than or equal to 0, or x and y, whatever you do it. Usually with the graphing format, we'll use x's and y's instead of x1 and y1. So here's a problem. The first one is to graph some inequalities. So every inequality that you graph correctly, you'll get a point. That involves graphing the correct line and shading the correct side. So this problem is going to be 20 points because there's so much to do in it. So make sure that you know how to graph lines, you know how to shade them correctly, you know how to find the points of intersection, the corner points, and then you know that you have to plug the corner points into the objective function in order to find, in this case, the maximum. So this is the one problem that you're going to see from chapter 5. Most of the other stuff is going to come from chapter 6. And as you can see on this particular sample exam, there was a heavy focus on word problems. So this one, and what I'm asking for is to list all the variables and what they represent, the decision variables, x1 equals this, x2 equals this, x3 equals this. Write down the objective functions, and then write down all the inequalities, the constraints for each problem. Something similar, but this one says solve the problem, whereas this one up here says don't solve the problem, just set it up. Number 4 here is that, okay, this is a initial simplex tableau. Okay, so I have to share something with you here. Most of the time in our current textbook, they always put the objective function right before the right-hand side. This book I was using before with these sample exams, it put the objective column all the way to the left. But other than that, you would interpret these matrices in the same way. This problem asks you to go through a couple of row operations. All of the work that the calculator does behind the scenes, all those row operations from initial matrix to final matrix, it does all those tedious calculations for you. But I want you to know what the calculator is doing and how to go through a row operation here. So I want you to convert this to another version that might not lead you to the final version, but still, what would be the matrix after you went through one row of row operations? And then write out the tableau, the initial tableau from this. And then ask yourself, is the tableau that we see here, is it the final solution? Or is it an intermediate solution? And then finally, write the tableau. No, that's it. Just, is it the optimal solution? This one kind of bleeds to the next page. All right, so I could give you either a maximum problem and a minimum problem and just say, write the initial simplex tableau. It's much more complicated with a minimum problem than it is with a maximum problem. And then here is just your generic, solve this minimum problem, just like the one that you experienced, the last problem on the group worksheet. Here's a minimum problem, go through all the steps, solve the problem. And then one more word problem. You can expect to see a word problem, a minimum word problem, and a maximum word problem. Okay, now, given that all of this stuff is going to be on the midterm, which problems would you like to see? And if you don't care or you don't know, then I'll just go through them in order. Chapter 5, and then chapter 6, setting problems up. doing some row operations, getting a problem, setting up the initial simplex tableau, solving a couple of abstract problems, no context, no word problem, or solving a word problem. Any preference? Okay, I'm not seeing any. And excuse me for going through these quickly because I want to try to get through as many of these as I can. I trust that you will ask questions if you have them. All right, the first thing here, we're going to set up an equation. I noticed just from the intercepts that if x is 0 or x is 8, y is 0, and if x is 0, y is 8. 0, 8 works in there, and 8, 0 works in there. So I'm going to graph that line. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. So here's the first line. Graph it. And at some point, I will label it x plus y equals 8. I'll notice that 0, 0 would work in this inequality because 0 plus 0 is indeed less than 8. So I'm going to shade toward 0, 0. Well, if this is my graph and 0, 0 is down there and it's a solution, I want to shade underneath. So I'm going to shade underneath that line. The next one, I'm just going to use intercepts. You don't have to use intercepts. I'm just going to use them. If x is 1 and y is 0, then x would have to be 1. And if you let y be 0 or x be 0 here, then y is going to equal negative 3/4. All right, so I have 1, 0, which is right there, and then 0, negative 3/4, which is about right there. And I'm going to connect those 2 points together. And let's say it's right there. So 1, negative 3/4, 8, and 8. Again, I'll check 0, 0 up here. And if you have 0 plus or minus 0, you're going to get 0. So 0 less than 3 is a true statement. So once again, I want to shade the 0, 0. So that means I'm going to shade above this line here. So now the region in question is all of this. All right, the final one, this one here. I might not graph intercepts. I could, I suppose, here. But other points might be better, like 5, 3. No, 3, 3. 15 minus, nope, that's not going to work either. I guess it has to be negative 3, because then that would be negative 15 plus 6. All right, so you can play around with other points, and you might get lucky and find some integers, but if you just do intercepts here, you have 0 and 9/2, 4.5. And then if y is equal to 0, then x is equal to negative 9/5, which is negative 1.8. All right, so let me graph this last line here. 1, 2, 3, 1, 1, 2. Oh, there it is. Looks like we hit a point on one of our other lines. Here's your negative 3, negative 3. And then we have negative 1.8, 0. That's about right there. And then we have 0, 4.5, which is about right there. All right, I'm going to graph this one. There it is. And for this line, I'm going to try 0, 0 again. I notice that 0 is greater than negative 9, so we're going to shade towards 0, 0 again. Here's 0, 0. So we're going to shade down under this line here. All right, if we shade as indicated, those are our only 3 inequalities. So this here is the feasible region. Turns out to be a triangle in this case. You can confirm, it looks like, this point right here is 1, 2, 3, 4, 5, 1, 2, 3. It looks like 5, 3. You know, 5, 3 works there. This is 5x minus 2y equals -9. This point right here looks like it's 1, 7. And you'd want to check that 1, 7 works in both of the two lines that come together to intersect that. You'll see that they do. So it looks like we have 1, 2, 3 corner points of that bounded region. So the answer to 1, which basically says graph the solution set, here's the solution. Identify all boundary points, corner points. So the corner points, or the boundary points, we have 3. They are 1, 7, that one, 5, 3, that one, and -3, -3. 3 corner points in a triangular region, 3 vertices. All right, now we have to evaluate our objective function. In this case, it's a z, -5x plus 4y. And we're going to evaluate z for each of our 3 corner points. And since this problem is a maximize problem, we're going to choose the largest of the 3. So this one would be -5 times 1 plus 4 times 7. It's 23. This one would be -5 times 5 plus 4 times 3. It's -8. Nope. -13. -5 times -3 plus 4 times -3. 15 minus 12, that's 3. When you compare 3, -13, and 23, the largest of those numbers is 23. So off to the side, we're going to say the max is 23. It occurs when x is equal to 1 and y is equal to 7. So here's the corner point that we're talking about, and the z value here is 23. The z value here is -13, and the z value here is 3. And of the corner points, the largest z value is this one here. So here's the answer. It occurs at 1, 7. So part C, really all that's involved is that you just put the corner points into a table and evaluate z. I might ask you if the region is bounded. Okay. Again, I'll ask for questions if you want to see any of these. Yeah, I'll upload these sheets, what we worked on today. But what's better already in e-learning is blank exams like you see, like this one, but with the answers afterwards. So they're already up there. Worked out solutions, not just the answers. So what I'm doing right now, there are 3 different exams in e-learning where you can see the same thing. And I'd recommend that you do the test, the blank test, and then go check the answers out at the back. And the questions that you didn't do well on, those are the ones that you should focus on those other 2 exams. All right, so circle the element where you would pivot. All right, so this one here is one on the row operations. We have to identify, usually we identify the largest negative number in the bottom row, and that's 6. And then we choose a positive number in here. If we take the right-hand side and divide by the x1 number, we get 2. And here, if you take 10, 4, you get 2.5. So if we choose the smallest of those 2, we would choose this one right here. But I just need you to go select a legal pivot number so that you can do the rest of the problem. So if we choose this to be a pivot, our goal is to make this 3 a 1 and everything else in that column zeros. So we're going to do row operations to create a 1 here, a 0 here, and a 0 here. that would change the basic variable of the first, or the non-basic variable of the first row to be x1. All right, here's the pivots. All right, the first thing I'm going to do is I'm going to take row 1 and divide it by 3, and that becomes the new row 1. I need to put a 1 there. This is an equation. I need to put a 1 there. So I'm just going to divide this by 3, and if I divide this by 3, I have to divide the whole equation by 3. 0 divided by 3, 0. 3 divided by 3 is 1. 4 divided by 3, I'm just going to write the fraction. 1 divided by 3, 0 divided by 3, and 6 divided by 3. So I've got my 1 there. Okay, so imagine you have this row here. We're going to take row 1, and if we multiply it, notice there's a 4 in this spot. If we multiply this 1 by -4, then this 1 would become -4, and then I can add it to this 4, which is row 2, and that's going to put a 0 in this spot. So then I would take everything that I have resulting from this row operation and dump it into row 2. So if I take this row and multiply it by -4, I'm going to get 0, -4, -16/3, -4/3. 0 times -4 is 0. 2 times -4 is -8. So that's -4 times row 1. I want to add that to row 2. Well, here's row 2. So I'm going to write it directly underneath. And then I'm going to add 0, 0. All right, so this is 3/3. So I'm going to have -13/3 here. Add those, -4/3, 1, and 2. This becomes the new row 2. So in this row, I have 0, 0, and that's really what I wanted. I wanted to put a 0 in that spot right there. -13/3, -4/3, 1, and 2. All right, finally, I want to put a 0 here so that I have 1, 0, 0. So once again, I'm going to take my row 1, this row, and I notice there's a -6 here. So if I multiply this 1 by 6, then this is going to be 6. And then if I add that to row 3, I would be adding 6 with -6, which would give me a 0. And I'm going to let that be the new row 3. All right, so here is 6, row 1. Here's row 1. If I multiply 6 by 0, I get 0. If I multiply the 1 by 6, 6. If I multiply 4/3 by 6, the 3 will cancel with the 6, leaving 2. 2 times 4 is 8. If I multiply 6 times 1/3, I get 2. If I multiply 6 by 0, I get 0. If I multiply 6 by 2, I get 12. So if I multiply this whole row, row 1, by 6, this is what I get. Now I'm going to add that row, or that 6 times row 1, to row 3. Well, here's row 3, 1, -6, -5, 0, 0, 0. I'm going to add those two together, column by column, and this is what I'm going to get. Now this becomes the new row 3. So down here, I'm going to put 1, there's my 0, 3, 2, 0, 12. So after one round of row operations, this is what the matrix will look like. These are the calculations that the calculator does behind the scenes for us. All right, so here it gives you kind of a clue. When you're done, the pivot column should contain all zeros except for the pivot value, which would be 1, and then enter the resulting matrix. So there it is. And then it says write out the solution given by the Tableau in part B. So what are the solutions? What is the solution here? says give the value for all variables, including the slack variables. So to do that, we're going to identify the non-basic variables of each row, just like you did in the group work. You see the 1 here with all zeros. So now x1 is the non-basic variable of row 1. For row 2, it's s2. There's your 1, zeros everywhere else. And for row 3, there's your 1, zeros everywhere else, and that corresponds to p. So p equals 12. S2 equals 2. X1 equals 2. All of the other variables are basic variables, so they take on the value of 0. So we have x2 is not yet listed, it must be 0. S1 is not listed, so it must be 0. And then we've got 1, 2, 3, 4, 5 variables, and we have each of them there with values attached to them. So write out the solution that is given in this tableau, give the value of all variables, including the slack variables. So this is what they're after. So the max, okay. So is this, and then this last question says, is the solution in part C this solution? Is it the optimal solution? In this case, is it the maximum? Does it give you the maximum? And the answer is yes. And the reason is that there are no negatives in the bottom row. As soon as you see no negatives in the bottom row, then you've got the final solution. So the solution would be the max is 12. It occurs when x1 equals 2 and x2 equals 0. So notice when you write out the actual solution, you don't need to write out the slack variables. Those are kind of dummy variables. Those were created just to enable us to be able to do the problem using the simplex method. So a little bit of the mechanics of row operations. You can get good enough at these. This one just says write out the initial simplex tableau. You can get good at these where you can go right to the tableau from this. So for example, this one here, I notice there's an x1, an x2, an x3, an x4. I know that there are 1, 2, 3 non-negative, non-negative constraints that are the significant constraints. This is a maximum problem because we have all less thans there. I know I'm going to need a slack variable here and a slack variable here and a slack variable there. So I can pretty much go to x1, x2, x3, x4. I have 4 variables in there, so those have to be part of the initial simplex tableau. I have S1, S2, S3 because there are going to be 3 slack variables. Then I have the objective function and then the right-hand side. So we list the constraints first, and there are 3 of them. And then we list the objective function with negatives. So if we start with the first constraint, you have 1, 2, 3, 4, and then S1 is going to be in that one. So S1 takes the constant 1. All the other slack variables are 0. P, there's no P in that inequality, and then the right-hand side is 5. Now the next one, 2x1, but there is no x2 in this constraint, so I'm going to put 0x2. And then 4, 6. This constraint is going to be written as an equation, and it's going to contain S2. So I want to put a 1 next to S2 in the S2 columns and zeros for the others because those other variables do not appear. And then 8 over there. And the last constraint doesn't look like there's an x1 anywhere, but 9x2, 7x3, 5x4. And then there's going to be plus S3, the third slack variable, but there's not going to be the same S1 and S2. No P in that equation either. And then we have 3. Okay, then we go up to the objective equation. Now remember, we're going to have to take the 4x1 over, the 6x2 over, and so on. So they're all going to be negative on the left-hand side, and the right-hand side is going to be left with a 0. And you're going to have 1p. There aren't going to be any slack values in the objective row. And then you just pick out the 4, 6, 8, and 10. All right. So this is the initial Simplex Tableau. And here were the instructions. Write the initial Simplex Tableau for each of the following. So at this point, you can stop and say this is your answer. All they wanted is the Tableau.